Alright, this will be part B on the lesson 7.4, and we're still looking at radical and rational expressions, and we're going to add using addition and subtraction. Oops, sorry, there's a little crooked there. And then multiplication as well. So we already looked at division and powers and that kind of stuff. So now we're going to look at adding and subtracting first. Okay, so when you're looking at a rational or radical expression where we have, square root of something times a number, and we have to add them like this. Okay, a couple of rules we're going to do is we're going to add the likes. Okay, so the things that are likes would be these two square root of 2. So they're the same. Okay, and so is this. Okay, so we always want to make sure whenever we're doing these addition and subtraction that the square roots we're looking at are the same. Okay, so then we would we were going to do the reverse of the distributive property, do that math, and then put them back together. And I'll show you that here in a minute. But the one thing you do not want to do not add those that are not likes. And I'll show you here in a minute examples of that. So I kind of have the answer over here, though. You see it. So I take the 5, and I add it to the 7, and then I minus the 6. So we got 5 plus 7 is 12, minus 6 is 6. So this would be 6 square root of 2 simplified. Okay, so we just take things outside. The thing under the radicand would be 2, which stay the same. Okay, so let's look at another example here, a little bit more complex. One's a little bit different. So here we have 10 square root of 7 plus 5 square root of 11 plus 4 square root of 7 minus 6 square root of 11. Okay, so what we're going to do is we're going to put these together, and then we're going to put these together. So then we're going to do the likes. So we're going to do 10 plus 4 square root of 7, and then we're going to do the other one. So we're going to do this 5 plus 5 square root of 11. I'm sorry. Let me pause that for a minute. Reset. Okay, so we're gonna do the addition here. 10 plus 4 is 14 square root of 7, and then we're going to have 5. We're going to add that to 5 minus 6. Okay, and then we're going to have that square root of 11. So then 5 minus 6 is negative 1 square root of 11, and in the end we get 14 square root of 7 minus 1 square root of 11. And that's as simple as we can get it. And you could even write this without the 1. We could also just write 14 square root of 7 minus the square root of 11. Okay, so that's your addition subtraction. So you look for likes, add them to or subtract them using your addition subtraction, and then sometimes you might have to separate them out. We got the square root of 7 here, square root of 7, do your arithmetic there, and 5 times the square root of 11, and negative 6 times the square root of 11. We'll do that math and then put them back together. So that's addition subtraction. If we keep going, we have unlike radicals, where you have one that none of them are the same, right? So here we have 2 square root of 18 plus 2 square root of 32 plus square root of 72. So what we need to do is we need to find radicals that are likes. Okay, so we're just going to look at these and see if we're going to simplify these. So here we're going to go to the square root of 18. We could break that down into the square root of 9 times the square root of 2, right? And let's see if we can get this to be the same. So perhaps we get square root of 8, no, so 16 maybe. So 2 times the square root of 16 times the square root of 2. Okay. And you're going to see square root of 2, square root of 2. That's going to work out in the end. Okay, then 72, we're going to go with, looks like 9 times 8, yep. So square root of 9 times the square root of 8. And then we could do, for this one, we can even get rid of the square root of 8, right? Let's do that. Let's just erase that. And we'll just do times the square root of 4 times the square root of 2. And it kind of guides us because we're trying to get to that square root of that, right? So here we have 2 times the square root of 9. 2 times 3 is 6. Square root of 2 plus square root of 16 is 4. So 4 times 2 is 8. Square root of 2 plus the square root of 9 is 3. And then this is square root of 4 is 2. So 3 times 2 is 6 times the square root of 2. And then we can just add them together. 6 plus 8 is 14. 14 plus 6 is 20. Square root of 2. It's an example of that. Okay. So let's look at an additional one. So here we have 4 square root of 54 plus 2 square root of 24. So we're going to look for some ones that we can divide into. Okay. Looks like here 4, I think 9 times 6 is 54. So square root of 9 times square root of 6. So we're probably going to see that with this one, right? So here we're going to go 2 times the square root of 4 times the square root of 6. I'm picking these 9 and 6's because they're square roots and I can divide them out and I'll be left with like radicals, right? So 4 times the square root of 9 is 4 times 3 is 12. Square root of 6 plus 2 times the square root of 4, which is 2, is 4 square root of 6. And then I'm just going to add them together. 12 plus 4 is 16 square root of 6. Okay, so that's that one right there. We'll do one more of these. These are kind of tricky. So let's just do 3 square root of 45. So what do we got for this one? Looks like 9. 3 square root of 9 times square root of 5. So we're probably looking for this one in these. So 20 plus, this is going to be square root of 5 times square root of 4. Get that 5 again. And then this is probably going to end up being 5. So we're going to look at 245. So let's go, 5 is going to go into that. So we'll go square root of 5. And it's going to go into that 4 times. And then 43 times square root of 43. And that doesn't look right, does it? Let me pause this, get my calculator out. Hold on. So I have 43. This actually should be 49. And get my calculator out. And then we can probably do this again. Let's see, 49. So this would be square root of 7. No. So I'm sorry. Square root of 49 is actually a perfect square. I don't need to mess with that, right? So let's just get rid of this. Okay. So then we'll have 3 times the square root of 9, or 3 times 3 is 9 square root of 5, plus square root of 5 times square root of 4, which is 2 square root of 5. And then we're going to minus that. We're going to have 49 square root of 49, which is 7 square root of 5. Okay. This just comes to the front. So then we do it. 9 plus 2 is 11. 11, and we'll just take it out here actually. 9 plus 2 minus 7 square root of 5. So 9 plus 2 is 11. Minus 7 is 4. So in the end, the answer is 4 square root of 5. So that's unlike radicals. Let's look at one more thing, and we'll be done. So here is multiplying radical expressions. So what you do is you multiply likes, and then you simplify. So here we have 3 times the square root of 2 times 2 square root of 6. So here we're going to have 3 times 2 is 6 times the square root of 12. Okay, and then what we do, is we take this 12 and reduce it. So 6 times the square root of 4 times the square root of 3. So 6 times the square root of 4 is times 2 square root of 3. 12 square root of 3 is the answer for that one. Let's look at one more example and we'll be done with our notes. So here we got 2 square root of 6 times 7 square root of 3. So we're going to multiply those things outside the radicand. 2 times 7 is 14, and 6 times 3 is square root of 18. Then we're going to try to do something with this if we can. So 14, and looks like 9 goes into 18. That's your perfect square. 9 times the square root of 2. This is then going to be 3, so it's going to be 14 times 3 times the square root of 2. It looks like that comes out to be 42 square root of 2. And that's your answer. So that's kind of how you do these. I think you're ready to go into the next part of the homework. Add these to your notebook, and I'll see you in class.